Okay, good day everybody, and welcome to the Learner's Corner. How do you do? So today we shall be discussing an interesting topic, which is electrolysis in chemistry. Okay, so we have electrolysis on the board. Electrolysis as a topic tries to explain to us what happens to a chemical compound when an electricity is being passed through it, when that compound is in molten form or as a solution. So it gives it the definition. So electrolysis is defined as a disintegration of chemical compounds when electric current is passed through it in a molten form or as a solution. So let me write it down. Say this is the disintegration of chemical compound when an electrical electric current is passed through it in molten form or as a solution. So this is the definition of electrolysis. We say electrolysis is the disintegration of chemical compound when an electric current is passed through it in molten form or as a solution. So there are certain things in which I want you to pick out from this definition. Number one, we talked about disintegration, and we also talked about chemical compound. Then we have electric current, and also we have molten form or as a solution. So in order for electrolysis to occur, the compound must be in molten form or must be a solution. And what it means for a compound to be in molten form or to be a solution means that compound must be mixed or must be diluted with water. So that's what it means. Then there are certain terminologies in which we need to know in order to understand more of what electrolysis is talking about. So one of it is we need to understand what an electrolyte is. We need to understand what an electrolyte is. So I will state the terminologies and explain it. So we'll talk about electrolyte. Okay, so in electrolysis you'll be hearing electrolytes. So electrolyte simply means that chemical compound that has the ability to to conduct electricity. So electrolyte is a chemical compound that has the ability to conduct electricity. So that's it. Electrolyte, any compound that has the ability to conduct electricity in molten form or as a solution is called an electrolyte. So for example now, around us, what we know or what is an electrolyte around us, or the common electrolyte around us, is sodium chloride. The sodium chloride that we know, this is the common source. So when we have sodium chloride and water, it gives us what? An electrolyte. So let me just say, in a situation where you are making some connections and you run short of wire, you can use sodium chloride and water. Then when you mix it together, it becomes a solution of sodium chloride. You can use that solution in order to complete the circuit. So this is it for electrolyte. Then the next one which we are going to talk about is electrode. Okay, we'll talk about electrode. Electrode is a pole. It can either be a negative or a positive pole through which electric current flows into the electrolyte. Is a pole through which electric current flows into the electrolyte. So let me write it down. This is the pole through which electric current flows into the electrolyte. So this is it. Electrode is a pole. It can be negative or positive pole through which electric current flows into the electrolyte during electrolysis. So now talking about the electrode, we have two types of electrode. Actually, we have the positive and we have the negative. So the positive has a name which is the anode, while the negative has the name which is cathode. So we have cathode and we have anode. These are types of electrode. Then also we are going to talk about what an electrochemical cell is. But before I talk about what an electrochemical cell is, I want you to understand the difference between an electrolyte and a conductor. Remember I told you that an electrolyte is a chemical compound that has the ability of conducting electricity when they are molten form or as a solution. Also, if you remember carefully, you know also that conductor also conducts electricity. But now you ask yourself, what is the difference? Although they have similarity, which is conduction of electricity, the difference there is that conductor conducts electricity because of the flow of electron, while an electrolyte conducts electricity because of the flow of ions. So these are the major differences. So let's talk about electrochemical cell. So talking about electrochemical cell is just a setup in which electrolysis occurs. So I'll be using a picture to show you, then I'll also explain it. When we talk of electrochemical cell, we need to have a container, and the container is going to contain electrode, which is going to be positive and negative electrode. Then inside the container we are going to have an electrolyte. So this is going to be electrolyte. Okay, let's name this container, and this is going to be our electrode. Remember, this electrode can be cathode or anode according to the side in which they bear. So here is our conducting wire. Let me just say this battery. So now let this be positive and let this be negative. So this is an electrochemical cell. So the whole setup of electrolysis happens in an electrochemical cell. Here we have a container containing an electrolyte, and inside that electrolyte we have electrode through which electric current passes from the battery into the electrolyte. So this is it. Then this is what an electrochemical cell looks like. Look at it. So there's something that happens when a compound is being mixed with water, or when a compound is in a solution. That is what theory of ionization. For example, I've been using sodium chloride as an example, and I'm going to use it because that's a common compound in which we find around us. So I hope you've gotten this. So let's just say, for instance, we have sodium chloride. When we have sodium chloride on this spoon, it's going to be a compound, but when we mix it with water plus H2O, something is going to happen, and the thing that is going to happen is what is called ionization. That is the splitting of all these things into different ions. So these ions are going to be split, and we are going to be having sodium ion, we have chlorine ion, we have OH ion, and also we are going to have hydrogen ion. So this is it. This is what happens during ionization, or when a compound is being mixed with water. Ionization is going to occur. We are going to have what ions of that compound. So we have sodium ion, chlorine ion, hydroxide ion, and hydrogen ion. So now let's just say, for instance, we have this as an electrolyte inside this container. If you have this as an electrolyte inside this container, something is going to happen. Now I want you to know that I told you already that we have two electrodes, and the positive one is called the anode, while the negative one is called the cathode. So now something is going to happen. Remember already I've told you that when we mix a compound with water, that the ions are going to be split. So the ions here are already split. Let's just say they are sodium chloride. We have sodium here, and we have chlorine, and we have OH, and also we have hydrogen. So now something is going to happen. Now I want to also tell you that the positive ions, which are the positive ions, which are the cations, will move to the cathode. Okay, let's just say already you know that positive and positive doesn't attract, rather they repel. So positive and negative will always go together. So that is why an ion like sodium during electrolysis will move to a negative cathode. So we move to a negative electrode, which is cathode. So that is what is going to happen. The positive ions are going to migrate to the negative electrode, while the negative ions will migrate to the positive electrode. And now when they migrate to the electrode, something is going to happen. One needs to be discharged at that electrode. So first of all, I want you to understand to this point that sodium and hydrogen are positive ions, and because of their positive ions, they will migrate to the cathode, which is the negative electrode, whereas chlorine and hydroxide ion will migrate to the anode because of what? They are negative ions. And when they migrate to the ion, there is need for one of the ion to be discharged at the electrode. So now the problem becomes, now which one will be discharged? So in order to solve the issue, or in order to solve the problem of the one that will be discharged at the electrode, there are certain rules that governs it. So that rules, we are going to be looking at it now. Okay, so let me say factors for preferential discharge of ions during electrolysis. So there are factors that affect this discharge of ions at a particular electrode. So the first factor is the position of the ion in an electrochemical series. So the first one is position of ion in an electrochemical series, and the second one is concentration of ion. The second one is concentration of ion. And the third one is going to be nature of the electrode. So remember I said the position of ion in an electrochemical series. Then the second one is concentration of ion. Then the third one is nature of the electrode in which you're using for the electrolysis. So I will explain this one by one. So let's start with position of ion in an electrochemical series.